Good evening to total. My name is Tae-Shiwen. My twin number is AE230051. Today I will present the project of multivariable calculus. In question 1, from the equation given x squared plus y cubed equals to 4, in part A, we need to find the y prime by solving the equation for y and differentiating directly. So from the equation given, we let y equals to cube root of 4 minus x squared, then we differentiate the y, we will get the y prime equals to negative 2x over 3 times 4 minus x squared power of 2 over 3. Then in part B, find the y prime by implicit differentiation. So from the equation given, x squared plus y cubed equals to 4, we implicit differentiation the equation. Then we will find that the y prime is equal to negative 2x over 3y squared. Then in part C, check that the derivative in part A and part B are the same. So from the part A, y equals to cube root of 4 minus x squared. Substitute into the result of part B. Then we will get the y prime is equal to the part A. So as a result, the derivative in part A and part B are the same. In question 2, for the equation given x over y cubed equals to 1, in part A, find the y prime by solving the equation for y and differentiating directly. So in part A, we let the y equals to x power of 1 over 3. Then we differentiate y. Then we will get the y prime is equal to 1 over 3x power of negative 2 over 3. Then in part B, find the y prime by implicit differentiation. Then from the equation given, we differentiate by using the quotient root. Then we will get the y prime is equal to y over 3x. Then in part C, check that the derivative in part A and part B are the same. Then from the part A, y equals to x power of 1 over 3 substitute into the result of the part B. Then we will get the y prime is equal to the part A. So as the result, the derivatives are the same. Next, in question 3, we need to using the chain rule to determine the delta of W over delta T and delta W over delta C as. Then, from the question given, W equals to square root of x squared plus y squared plus 6z over y. Then x equals to sine p, y equals to p plus 3t minus 4s, z equals to t cubed over s squared. Then p equals to 1 minus 2t. To do this, we will need the following tree diagram. Then, the first step, we need to explain the delta omega over delta t using the chain rule. Then we will explain delta W over delta t equals to delta W over delta S times delta S over delta t plus delta W over delta Y times delta Y over delta t plus delta W over delta Z times delta Z over delta t. Then we find out the individual partial derivative for delta W over delta X, delta W over delta Y, delta W over delta Z, and the delta S over delta T, delta Y over delta T, and delta Z over delta T. Then we find out the partial derivative. Then we substitute into the delta W over delta T. We will get S over square root x squared plus y squared times negative 2 cos p plus y over square root of x squared plus y squared minus 6z over y squared plus 6 over y times 3t squared over x squared. Next, we need to find the delta w over delta s. We expand it, then we will get delta w over delta s equals to delta w over delta s times delta s over delta x plus delta w over delta y times delta y over delta x plus delta w over delta z times delta z over delta x. Then we find out the individual partial derivative. Then we will get the value. Then we substitute into the delta w over delta x. We will get negative 4 times y over square root x squared plus y squared minus 6z over y squared plus 6 over y times negative 2t cubed over x cubed. Next, in question 4, the problem is to calculate the value under the surface z equals to 3 plus x squared minus 2y over the region D divided by s from 0 to 1 and y from negative s to x. The solution is the value v can be calculated as v equals to 3 plus x squared minus 2y dy dx for s from 0 to 1, for y negative s to x. Then we integrate the dy, then we will find that, and then we integrate the ds, we will get the answer is 3.5 unit cube. Next, in question 5, calculate the volume between the surface z at xy equals to 3 minus x squared minus y squared and the surface z xy equals to 2x squared plus 2y squared. In the first step, we let the fxy equals to the gsy. Then we simplify it. We will get the equation of circle, which is radius is equal to 1. Then we find the volume from the equation given. Then we set the range bound on the R is 0 to 1. Then from range bound of theta is 0 to 2 pi. Then we integrate the inner integral. After that, we find that the outer integral, we will get the final answer volume is 3 over 2 pi units cubed. In question 6, find the value of the tetrahedron bounded by the coordinate plane and the plane through the 3 points. This is graph I sketched. From the sketch graph, we define the z equals to 1 minus s minus 2 over 3y. Then by using the double integrals, we find that v equals to 1 minus s minus 2 over 3y dy dx from 0 to 1 and from 0 to 3 over 2 1 minus x. Then we solve it inner integral and the outer integral. We found that the volume is 1 over 4 units cubed. Thank you.
My name is Teo Chi-san, matrix number AE230071. So now I will explain the question 7 until question 12. So for the first question, we need to evaluate the triple function, which is y cos z power of 5 dx dy dz. So I will use the Mapper software to solve this question 7. So for the right side is the code for the Mapper software of the question 1. For the question 7. So the final result I will get 0.2524. So next I will explain the question 8 until question 11 by using the MATLAB software. So for the question 8, we need to evaluate the triple integral function also. So for the right side, this is the MATLAB code for the question 8. After we run the result, it will appear the final value for the integral is 312.5 for the question 8. So next, question 9, we need to sketch the vector field for the function equal to 2xi minus 2j. So for the right side is the MATLAB code for the question 9. After we run it, we will get the vector function for this. We will get the figure for the vector field for this function. So next is the question 10. We need to compute the gradient vector field for f equal to y squared cos 2x minus y. So for the right side is the MATLAB code for the question 10. After we run it, I will get for the x gradient is equal to negative 2y power of 2 sine 2x minus y. For the y gradient, I get 2y cos 2x minus y plus y power of 2 sine 2x minus y. So for the question 11, we need to evaluate the triple function where c is the helix given by tau t equal to cos t sine t 3t in the range between 0 smaller than t and t smaller than 4 pi. So right side is the MATLAB code for the question 11. So after we run it, we get the value of the integral is negative 3 pi multiplied with square root 10. So next for the question 12, we need to find the word required to move the object from x equal to 3 and also x equal to 7. The first is given by question, which is fx equal to x squared minus cos 3x plus 2. So we need to find the value of what. So for the right side, I will use the Mapper software to solve this question 12. So this is the code for the question 12. After we run it, this will appear the result of the integral, which is word equal to 340 over 3 plus sine 9 over 3 minus sine 21 over 3. That's all from me. Thank you.
Good morning, Professor. My name is Curtin, number matric AE230075, and I'm going to present about the question that I do, that is question 13 to question 16. So for question 13, we need to evaluate the surface integral for 6xy dx, where x is a portion of the plane x plus y plus z that equal to 1 that lie in the first octet and is in front of the yz plane. So we do it like this. Rxy equal to x equal to s, y equal to y, and z equal to 1 minus x minus y, and this limit that is 0, x equal to the limit of x is 0 to 1, limit for y is 0 to 1 minus x. And we find out using the metric, and then we can get the vector is I plus j plus k times with rx times ry. Okay, then we find the distance. For i's and ry, we sub the value inside. 1 square plus 1 square plus 1 square equal to square root 3. Then after that, we apply the formula inside. Surface integral, that is f rxy dot product with the distance of rx times ry. And then after we do the integral, then we can get the answer that is square root 3 over 4. And then is question 14. So, for question 14, we need to evaluate the surface integral for y plus z ds, where s is the surface whose side is the cylinder x squared plus y squared equal to 3, whose bottom is the disk x squared plus y squared smaller or equal to 3 in the xy plane, and whose top is the plane z equal to 4 minus y. Okay, so for this, we separate it to 3 surface integral. There is first one is cylinder, second one is top of cylinder, and the third one is the bottom of cylinder. So we can see at here S1, S2, S3. And also we find the same thing, that is the Rz theta, that is equal to square root 3 cos theta plus square root 3 sin theta plus z. And for the theta, we can know that the limit is 0 to 2 pi, and for z is 0 to 4 minus square root 3 sin theta. Integral for cylinder. So after that, we apply the formula inside. So for integral for cylinder, we using the double integral to find it. Then we apply the limit inside. Then we apply also this square root 3 sin theta plus z inside the formula. Then after that, we can do it out, and we can know that the integral for cylinder is 29 square root 3 pi over 2. And integral for the top of cylinder, so we do the same thing, and we put the value all inside, and we can get the integral for the top of cylinder is 12 square root 2 pi. And integral for the bottom of cylinder, after that, we also do apply the formula inside, and we put all our value inside, and we can get the integral for bottom of cylinder is equal to 0. And to know that the surface integral for this y plus z ds, as we know, just now I already mentioned that there's 3 surface integral that I separated out, and then we add all. We add it all, and we can get that pi over 2 square root 29 pi, square root 3 plus 24 square root 2. Okay, so for question 15, we need to determine if the following vector field is conservative. That is f equal to 6xi plus 2y minus y squared j plus 6z minus x3k. So for this question, we do it like this. So we also use the metric form, and we find it. Okay, so to find it, we use the metric form, and to find the unit vector, the normal vector. So for the normal vector, we apply the metric, and we can find out. For first one, we can find out that the after we apply all the partial derivative for y, for z at I, for j we use the partial derivative of x and partial derivative of z. For k, we use the x and y for the partial derivative, as we do in this metric form, and we can get that the vector is 3x squared j. Okay, so as the vector is not 0, so the vector field f is not conservative. Okay, so for question 16, so we also need to determine if the following vector field is conservative, and this is the question. Okay, so we also do the same thing as question 15, and we do this, apply the metric form, and we do the partial derivative, and we can get that the vector is 0. So when the vector is 0, the vector field f is conservative. Okay, so for question 17, we need to evaluate the surface integral for f ds, where f is equal to 3x I plus 2zj plus 1 minus y2 k, and s is the portion of z equal to 2 minus 3y plus x2 that lies over the triangle in the xy plane with vertices 0, 0, 2, 0, and 2, negative 4 orientated in the negative z-axis direction. Okay, and we do it like this. So we write out what we get. That is f. This is the f equation that the question gave us, and this is the s equation that the question gave us. And we draw it out. 0, 0, 2, 0, 2, 4. Okay, then we do the partial derivative for I, j, and k. So we can get that the phase angle is 2xi plus negative 3j minus k. And we do the unit vector. Okay, so this is a unit vector, and we do the dot product also later, at here. And then the dot product is like this, and then at here the comma is mean that this is I, this j, and this k. There's different thing at that is not the same one, so we cannot combine it all together. And so for I only times with I, j only times with j, k only times with k. So we can get the equation like this. Okay, so after that we do the surface integral. So I change the surface integral to the normal integral by times the unit vector, unit normal vector. I mean. Okay, so these two can be cancelled, and this is the equation that I get. Okay, so for this equation we know that the limit is negative 2 pi equal to 0. Negative 2x equal to 0 and 0 to 2. And this is the equation. Then we do all the calculation out integration, and we can get that the answer is negative 412 over 3. Okay, so the last question 18. Evaluate the surface integral f ds, where f equal to I plus zj plus 6xk, and s is the portion of the sphere of radius 3 with x is smaller or equal to 0, y is bigger or equal to 0, and z is larger or equal to 0, orientated inward toward the origin. Okay, so we do it like this. So we also write out all the things that we get. Okay, and also this is the r for phase angle, that is 3 cos the phase angle cos theta. Then this comma is also equal to another thing that is, this is I, this j, this k. Okay, so after that we do the multiplication for r theta and r phase angle. Okay, then we can get it, the negative 9 sin square phase angle cos theta I minus 9 sin square phase angle sin theta j minus 9 sin phase angle cos phase angle k. And then we also do the same thing as like previous question, that is we do the n unit vector, and this thing we didn't count it out because later that I will going to change the surface integral into the normal double integration, so we need to times it back, so I didn't calculate it out. Okay, so the part at up there I got to calculate out, and I times with the I, j with j, k with k. So this is the answer that I get. And after that I also apply the formula inside, so the surface integral f ds, and from this equation I change to this equation, that is normal integral. Then these two can be cancelled out, and then this the equation that I get, that is integrate 1 over 2 pi to pi, and integrate 0 to 1 over 2 pi, negative 9 over 2, bracket 1 minus cos 2 phase angle cos theta minus sin square phase angle cos phase angle in bracket 27 sin theta plus 162 cos theta d theta, d phase angle d theta. After that I calculate it out, I do all the integration, and I can get the answer 9 over 4 pi plus 45 is the final answer. Okay, so that's all for my presentation. Thank you.